Hello everyone and welcome to machine learning tutorials. In these tutorials, we present in clear manner real and applicable machine learning knowledge. This particular video is dedicated to ensemble learning in Scikit-learn and Python. In particular, we will explain how to implement voting classifiers in Scikit-learn. Okay, so let's first briefly go over the material that I will explain in this video. First of all, I will explain the basics of ensemble learning and voting classifiers. Then, I will explain how to implement voting classifiers in Python and Scikit-learn. I will explain the Python codes that you can see over here. And by the end of this video, you will be able to generate a nice graph that you can see over here. This figure shows the decision boundaries of the classifier, and it shows classification results for the training and for test samples. And finally, at the end of this video, you will be able to compare different classifiers and you will be able to evaluate their performance on the test data set. Before I officially start, I would like to mention a few things. First of all, those of you who are my subscribers or who follow my work know by now that I always create a post that nicely summarizes everything that I will explain in this video, and consequently, here's the post. Secondly, it took me a significant amount of energy, planning, and time to create this video and this post. And consequently, I kindly ask you to press the like and subscribe buttons. Thank you very much. Okay, so let's start. Let us suppose that we ask a question to a large number of people. This can be either an easy question or a more difficult question. A difficult question will be the following one. What's the distance between Earth and the Moon? Most likely, a single individual will not give us the most appropriate answer. However, if we can somehow analyze all the answers and pick up either the most frequent answer or pick up the answer according to some weighted measure, then most likely such an answer will be the correct answer. This approach is a very well-known approach in statistics, and it's often referred to as the wisdom of the crowd approach. Over here, you can click on this link, and this link will lead you to the Wikipedia page explaining the wisdom of the crowd. Loosely speaking, this is the main idea of the ensemble learning. We train a number of predictors on the same data set or on smaller data sets that are samples from the same larger data set, and then we combine the predictions of all the predictors in order to choose the most appropriate prediction. Of course, there are a number of approaches for implementing this idea. In this tutorial, we focus on voting classifiers. The voting classifiers are relatively simple to understand, and I will use this graph over here to illustrate them. Let us say that we have a binary classification problem. Furthermore, let us assume that we have a data set that we can use for training. This is our input data set and this is the output data set. The output data set consists of two classes, either class 1 or class 2. So this is a binary classification problem. Now, we use this data set in order to train 5 classifiers. This is classifier 1, classifier 2, classifier 3, classifier 4, and classifier 5. After training these 5 classifiers, we pick one sample from the data set and we provide this sample as an input to our classifiers. For example, classifier 1 can give us the answer, so this sample belongs to class 2. Classifier 2 can, for example, provide the answer class 1, classifier 3 class 2, classifier 4 class 1, and classifier 5 class 1. In this case, the voting classifier will select the class 1 as the final answer, and it will say that this sample belongs to class 1. So what's the logic behind its selection? Well, the voting classifier will simply count the following quantities. We have 3 classifiers that predicted that this sample belongs to class 1. So we have a number 3. On the other hand, we have 2 classifiers that predicted that this sample belongs to class 2. Since 3 is larger than 2, by majority vote, we select the answer 1. So the sample belongs to the class 1. And that's the main idea of voting classifier. However, I have to mention that this voting approach is called hard voting. There is also soft voting that's based on probabilities. However, I'm not going to explain soft voting in this particular video. Hard voting strategy is also called the majority of vote or majority vote strategy. So let us summarize the voting classifiers. We train different classifiers on the same data set. Classifiers can be of completely different types, such as, for example, support vector machine, logistic regression, decision trees, random forest, etc. Also, the classifiers can be of the same type, however, the parameters of the classifiers can be different. For example, we can train a series of decision trees with different parameters. Then, the majority of vote strategy selects the final predicted class label of an input sample by analyzing the class label predictions of all the predictors in an ensemble of the classifiers, and by simply choosing the class label that appears most often. Okay, now that we have a basic understanding of the voting classifier and the majority of vote strategy, let us now explain how to implement this classifier in Python and Scikit-learn. So here's the plan. First, we will create 3 classifiers. The first classifier will be support vector machine classifier. The second classifier will be logistic regression classifier. And the third classifier will be random forest classifier. Then, we will create a voting classifier by aggregating these 3 classifiers in a single classifier. Then, we will compare the predictions of all 4 classifiers by using the accuracy measure. And finally, we will plot the decision regions. So let's see how to do that in Python. Before I explain the Python code that implement the voting classifier, it's very important to first explain the data set that will be used in order to test the classifiers. And here's the data set. This is the so-called Moons data set that's available in a Scikit-learn database. Basically, this is a binary classification problem, and here are the samples. We have 2 classes. We have class A, denoted by crosses, and we have class B, denoted by circles. We have 2 features, x1 and x2 features, and these features are x and y coordinates of different samples. For example, this sample over here will have x1 serving as an x-axis and x2 serving as y coordinate of y-axis. So the features will be organized like this. We'll have 2 columns. The first column will be x1, the second column will be x2, and over here are the real numbers representing x1 and x2. Now, what is interesting and challenging about this data set? Well, this data set is not linearly separable. So you cannot draw a line, a linear line, and separate all the samples of the class A and class B left and right or up and down from this line. Obviously, if you do something like this, if you're trying to make a classification boundary that is simple line, you will see, for example, that these samples are improperly classified. Consequently, you will have to have a more advanced boundaries, such as these type of boundaries, and these type of boundaries cannot be achieved by using a simple logistic regression classifier. You will need to do something more advanced. Okay, next we explain the Python code. The Scikit-learn library is implemented in this package called sklearn. Consequently, you need to install this package. Okay, the first step is to import the support vector machine classifier. It's called SVC. The second step is to import the logistic regression classifier called logistic regression. Then you need to import the random forest classifier called random forest classifier. Then here's the voting classifier that you need to import. Then we import the data set. Data sets is basically a database of all the data sets. We will be using the moons data set. Then we import the accuracy score. The accuracy score is a function that will be used to compare the predicted and the true outputs of the classifiers. Then we import this function train test split in order to split the data into training and test data samples. And finally, over here, we also need to import the standard scaler in order to scale the data and to standardize the data. And we are still not finished with importing all the necessary parts. We need to import this function that I wrote. This function is called visualize classification areas, and this function is provided in this Python file called functions, and here's the definition of this function. This function is basically used to generate these classification graphs. It's being used to generate these decision boundaries and to create these nice panels. All the codes are provided on my GitHub page, whose link is given in the description below. Okay, so the first step is to import all the necessary functions and packages. Good. After that, we need to create the data set for testing different classification methods. To create a data set, we will use this function makeMoons from the data sets. We specify number of samples to 200 and noise to 0.15. Now, since I want to create a video that's relatively short, I will not explain this makeMoons function. However, I created a tutorial that nicely explains this data set and makeMoons function. And you can find this tutorial by simply going to my web page and typing here moons and doing search. And then this tutorial over here explains the moons data set, how to create it, and how to generate this graph over here that represents the moons data set in 2 dimensions. Next, we need to split the original data set into 2 subsets. The first subset will be the train subset, and this subset is used to train the classifiers, or in other words, to fit the parameters of the classifiers. The second subset, called the test subset, will be used to evaluate the final performance of the classifiers once we have trained the classifiers. We do that by using the function train test split, and keep in mind that this function is imported from sklearn. It's imported over here. Next, we need to create a standard scaler. That is, we need to scale the input data, and the input data is xtrain and xtest. We need to scale the data since some classifiers are very sensitive if the features of the input data are not properly scaled, meaning that the features have dimensions or numerical values that are largely varying. So for example, one feature can be 0.1 and another feature can be in the order of 100, and this is not good for training. So we need to scale the data. That is, we need to standardize the data by reducing the mean, that is, by setting the data to have zero mean and by setting the data to have a unit variance. We do that by using these code lines. We first create a standard scalar, and then we apply the fit transform to xtrain, and we apply the transform to xtest. As the result, we obtain xtrain scaled and xtest scaled, and both of these input data sets will be zero mean and they will have unit variance. Next, we need to create the classifiers. We create the support vector machine classifier by using SVC. This parameter over here is not important. Next, we create logistic regression classifier. We specify the random state is equal to 42 in order to have reproducible results if we run this code several times. Then we create the random forest classifier with the number of estimators equal to 30. So let us create these three classifiers, scale the data, and split the data sets. Okay, so far so good. The next step is to create the voting classifier. In order to create the voting classifier, we will first create a list of tuples where every entry of this list will be a tuple formatted like this. The first entry of the tuple will be the name of the classifier, and this name can be an arbitrary name. Here I will call it SVM, standing for support vector machine. However, you can call the classifier as you wish. And the second entry of the tuple is the name of the classifier that we created. So here is the name. Similarly, the other two tuples follow the same naming conventions and the strategy. First we give a name and then we specify the object name. In the case of random forest, the name is random forest, and here is the object. Once we create this list, we will pass this list to the constructor of our voting classifier. So here's the constructor of the voting classifier. Again, keep in mind that the voting classifier is imported from Scikit-learn. The first parameter or input parameter of the voting classifier is the created list. This list contains all the classifiers that will be in the ensemble of the classifier, and we here specify voting to be hard. This parameter implements majority of vote. So let us create our voting classifier. Here it is. Okay. Next, we create the final list of tuples of classifiers. So I will append my original list with my voting classifier. I will call it voting, and I will specify the object name, and it is voting CLF. Okay. And let us see this list for a second. Here's the list: support vector machine, logistic regression, random forest, and voting classifier. Next, let us test these classifiers. We have now 4 classifiers. First, I will initialize an empty dictionary called classifier score that will track the accuracy of certain classifiers. Over here, we will iterate through the classifiers and compute the accuracy score. So I will go through the list of classifiers. I will perform the fitting process by specifying training scale data and the output data, training output data, and then I will do prediction on the basis of the test data for every classifier, and finally over here I will compute the accuracy score by comparing the test output with the predictions of the output made by the classifier, and I will append my list. So let's see how this thing works in practice and what are the results we obtain. Okay, so here I made an error since I didn't initialize this list, and now everything should be fine. So let us see the results. Okay, so here are the results. We can see that support vector machine has the accuracy of 0.98 on the test data set. Logistic regression, as expected, has the lowest accuracy since the input data is not linearly separable. Random forest has 0.99 accuracy, and the voting classifier has the accuracy of 0.98. Notice here that the voting classifier does not have the largest accuracy. This is because we included the logistic regression that kind of pushes down the accuracy, and the voting classifier kind of takes the majority vote of these three classifiers, and the accuracy is not the largest one since this logistic regression classifier negatively biases the final results. That is, it decreases the accuracy. However, you can see the basic principles of creating voting classifiers, of including different classifiers, etc. And finally, over here, I will call my function visualize classification areas in order to obtain nice visualization results. As I mentioned, this function is implemented over here, and I currently don't have enough time to explain this function. And you simply execute these code lines, you specify the name of the classifier, you specify the training and test data set, and you specify the name of the file. So this function will create a PNG file showing the decision boundaries and showing the classification results. And after some time, you will obtain all four graphs illustrating the performance of four classifiers. And here are the results. So these are the decision boundaries and classification results for the support vector machines. Then, over here are the results for the logistic regression. We can clearly see that a line shown over here cannot properly classify and separate the samples according to their class membership. So we know that logistic regression is not the best option in this case. However, we are still using it in order to demonstrate results. This is basically the random forest classifier. You can see how nicely the decision boundaries are formed. However, you can see that we don't include a sample. Then, finally, this is our voting classifier. And voting classifier combines everything and obtains, in my opinion, best decision boundaries. Okay, that would be all for today. I hope that you like this video. If you like the videos I create, please press the like and subscribe buttons. Thank you very much and have a nice day.